our next talk is on digital evidence and authenticating it, validating it. Speaker is going to be Stephen Harris, also known as Nix Intel, probably to many of you. He currently works as an OSINT specialist with Complex Inc. Is that right? Complex?
That's right. Yeah, Complex.
Okay, and I know their headquarters in Virginia. There's a bike trail I used. Unlike the Peloton people, I think both Stephen and I would rather ride outside, even this time of year. And there's a bike trail that goes right by there. So if you ever get to the HQ, ask for a bike.
You'll probably get there before I do, as you can tell from my accent. I'm not from that part of the world.
Yeah.
Okay.
Stephen has a background as a detective, worked in law enforcement for some years, specializing in cybercrime and OSINT, as well as digital forensics. He blogs at Nix Intel, but I will let Stephen get on with it here and tell us what he wants us to know.
Okay, thank you very much for that introduction, John. That was great. Okay, this talk is entitled Hash or It Didn't Happen. John just introduced me, so I won't repeat everything he said, but I have a long background in OSINT and cybercrime investigation. That's mostly been in law enforcement, although recently I joined Complex, we do some great OSINT stuff in cybersecurity. I have dabbled in digital forensics a little as well, and in the talk you'll see that influence and how it impacts on some areas of my OSINT work. And if I'm not on OSINT Curious, you can't find me there, you'll find me on my personal blog at nixintel.info. So this is the question that I'm hopefully going to answer in the next time period. How can I prove that my OSINT evidence is genuine and not manipulated or edited? So I guess if you're watching this, you have an interest in OSINT, or you do either do it as a hobby or professionally. And so this is for you. But particularly people who do OSINT in a situation where their findings at the end of their OSINT research are likely to be challenged. So if you are a private investigator, for example, or if you work in law enforcement, or if you are an investigative journalist and you're uncovering corruption and malpractice and things like that, so all the little digital artifacts that you build during the course of your case and you present at the end are likely to be challenged. And if you've ever been in the legal system, and if you've ever stood in a courtroom and you've presented your OSINT evidence, maybe you're trying to send someone to jail, or it's maybe a malpractice hearing or something like that, what you might find is if you have produced really good, really decisive OSINT evidence from your work on the internet, the defense lawyers will not attack the evidence that you got. They will attack how you got it. They will say, well, that's been manipulated, that's been altered. How do we know that's original? And if you do that in journalism too, you see, for example, with like Bellingcat, when they publish some of their open source work, people on the attack all the time. This is fake. This has been altered. This is forged. This is disinformation, and so on. So if you do OSINT in that kind of environment, you need to make sure that your work is defensible and that it's authentic. And so what we'll see throughout the course of this talk is how we can do that. And by the end of it, you will all, regardless of how you do OSINT, you will have a couple of little tools in your OSINT toolbox. We will just show you how to do that. And the technique, in 2 words, is called file hashing. It's a technical method to prove that the data you've gathered during the course of your OSINT investigation has not been altered and that it has not been tampered with. If you have any kind of background in digital forensics, this will probably be second nature to you. But I'm aware that this is an OSINT summit and most people will not. But we'll look at what file hashing is, the benefits it gives, and some of the problems it solves that can save us a lot of pain later on. So we'll do the principles first, and once we've done these, then we'll look at the practical stuff. So this is about as detailed in terms of text as this presentation gets. So In the UK, we're governed, anyone who practices digital forensics or OSINT research or anything to do with computers in a law enforcement environment has to follow what we call the ACPO principles. And one of them says this, it says, no action taken by law enforcement agencies, persons employed within those agencies or their agents should change data which may subsequently be relied upon in court. It's very wordy, and I prefer the ADAM principle. ADAM is an Australian model. It stands for Advanced Data Acquisition Model. That says much more simply, the activities of the digital forensic practitioner should not alter the original data. And if you are doing OSINT and you're gathering stuff from the internet, you're finding files, you're taking screenshots, you're downloading databases, you may not think that you're a digital forensic practitioner. But in one sense you are, and certainly when it comes to presenting your evidence in any sort of situation where it's going to be challenged, you need to show that you have not changed it. Because I can assure you, if you are stood in a courtroom, gripping the edge of the rail, and someone is asking, and the defense lawyer is asking you, how can you prove you haven't altered this? How can you prove this isn't fake? If you cannot show that it is still authentic, that you have not changed it, that's a really, really uncomfortable feeling. And regardless of where we do OSINT, it's much more professional, and we produce much more higher quality reports and products if we can show that we have not modified or altered our data in any way. So how do we do that? This is the first principle, which you're probably familiar with, and I won't dwell on it too long because I want to get to the more fun technical stuff. But all OSINT involves collection, and you saw in Nico's presentation earlier how you can plan for that, and he presented a really good model, so I won't repeat what he said. But all OSINT involves collection, and eventually after you go through various cycles of analysis and so on, then you come to your report at the end, whether that is a journalistic report or a threat intelligence report or a law enforcement case and so on. What you have to do as an OSINT practitioner is to show that the data you gathered during the initial collection when you were digging around the internet has not changed or been altered by the time you come to report. Because if someone wants to sue you or argue with you, you need to be in a position where what you're doing is defensible. And the way we do that is called the chain of custody. So I'm not going to mention the chain of custody too much, because it's not as fun or exciting as the more technical stuff, but just bear in mind throughout the presentation, whenever we're talking about continuity, chain of custody, this is what I'm discussing. It's making sure that when you've gone from A to B, there hasn't been any change or alteration in the middle. So let's have a look at an example. So the image at the top of the waterfall is an original image. One of the images at the bottom is an exact copy of the original, and one of them has been altered. Now, I will defy anyone to look at these and tell me of the bottom two images, which is the copy of the original and which one has been altered. And this is a slightly unusual example, but because I'm presenting this to you over the internet, it's much more easier to talk about images, because it's more interesting to look at than a row of server logs or a database, for example. But what I'm going to talk about applies to any kind of digital evidence that you might find, a file of any kind. Now, you cannot look at those bottom two images unless you have unbelievable eyesight and tell which one has been altered. But what we'll do, by the end of this talk, we will be able to prove beyond all reasonable doubt that the chain of custody in the handling of one of those images has been broken and the image has been altered, and therefore would be no use in any sort of situation where the evidence was going to be challenged. Now, I mentioned I've used images. It's quite easy to look at an image usually and tell if it's been altered. But what if one of the objects you found was an Excel spreadsheet that had 10,000 rows of data in it? Are you going to look through all those and check that each row, each cell hasn't changed? Or perhaps I'll give you a SQL database that has 1 million rows of data in it, and I want you to be able to prove to me that this database you found is the same as the original. Of course, you can't do that very easily. You certainly can't do it visually or manually. But what we'll do is we'll see that with file hashing, anything that is made up of bytes, which all objects in computing are, anything that's made up of bytes can go through this hashing process and it doesn't matter what the type of file is or how big it is, we will be able to prove for anyone who wants to know that it has not been altered, that it hasn't been changed, and that there is integrity running all the way through our work. Okay, so first of all, I'll mention, not going to go too deep into stuff, digital forensic wise, but one of the things I know is taught at SANS on the OSINT course, is a sort of a key part of OSINT work, is when we look at a file, looking at what we call metadata. We're all familiar with the content of a file, be that an image or a document of some kind, but usually within a file, there is what we call metadata, which is data about the data. It will say things like the software that was used to make the file, when it was first made, when it was altered. And with more complex files like photographs and so on, there can be huge amounts of data in there. Most famously in OSINT, we always look for, although we don't often find it, we always look for GPS information embedded in a photograph, because that will tell us where it was taken. And sometimes with criminals and fraudsters who slip up, they might produce a document that purports to be from one person or from one time and place. But sometimes we can look in the metadata and see that actually that's not the case, and they can betray themselves sometimes. So what you will often find is people will advise you to check the metadata, check the metadata, check the metadata. And whilst we should, but what metadata cannot do, and why it's not reliable as a form of authenticity, is metadata can be changed and altered in exactly the same way as the data in any other kind of file. So metadata by itself cannot prove originality or authenticity. And I'm going to show you exactly how that works. Now, the screenshot on the right is a photo I found on the internet with some EXIF data in. The screenshot below that is from an EXIF tool called EXIF tool, which allows you to extract information from photographs and other files. It's a command line tool, although there are graphic user interface ones, which we'll see shortly. But you can see here there is some metadata, including the time and date when the image was first taken, which was on the 23rd of October 2008. And there are GPS latitude and longitude coordinates to show us where it was taken. And there's all sorts of other information to go with the photograph as well. So do we trust that metadata? Well, after you've watched this, you won't trust metadata again. Metadata can be very easily altered, and there's a great resource for doing that. If you want to, it's a metadata editing tool, and it's at theexifer.net. I'll show you what it does very briefly, but you basically, you upload your file, your photograph to theexifer.net, and you can modify the photograph on the website and then download it, and the metadata will have completely changed. So that's what I did when I was preparing this talk with that photograph. So you remember the metadata said that the image was taken, created on the 23rd of October 2008. So I decided I would change the create date field to 2019, change the modified date to November 2019. I decided to put my own name as the copyright holder. So now if someone finds this image, it'll say copyright Stephen Harris, not the original photographer. What you can do with the GPS coordinates is actually you can upload the image and click on the map anywhere in the world, and it will automatically write those coordinates into the metadata. So this is great for editing. And I think Nico mentioned in the OSINT Curious panel before that one of his OPSEC practices is to see lots of false information about himself around the internet. If you want to do something like that, this is a great tool for producing false information. But in this context, we want to do the opposite of that and prove that our information is genuine and that it hasn't been altered. So having put that image through the EXIFer, I look at the metadata again, and it now says that the image was taken on the 21st of October 2019, so 11 years afterwards. And it says that I, Stephen Harris, am now the copyright holder. So can we still rely on metadata because it's really, really trivial and fast to edit it to make it say whatever we want? And I'm aware, especially if you've followed anything I've written about geolocation, you'd be aware, yes, we could look at those coordinates and check them against Google Maps to see that they don't match the photograph. That would be one way. But what if this photo was taken inside somewhere, or if you couldn't geolocate it, or if it was a different kind of file altogether, you wouldn't be able to do that. So just having metadata by itself doesn't necessarily prove the authenticity to the standard that we need. When I was preparing this presentation, this was a question that came up, so I'm just going to mention it. When you look at the metadata of a file, you'll see inside any file, it will say when it was modified, accessed, and created. That is metadata, but that's what we call external metadata. Most of the metadata in a file comes from the inside, it comes from the content of that file. But when we talk about file modification, creation, access, that data actually comes from your own operating system. What that means for us is if I had a photograph, for example, and I opened it on my computer, and then I sent it to Micah, and Micah opened it on his computer, everything would be the same, but this part of the metadata would be slightly different because it was opened on a different operating system at a different time. So, but external metadata does not affect the file hash, as we'll see shortly. So hashing overview, what is hashing? If you don't know what hashing is, hopefully this will make it clear to you and you'll want to start being able to use it in your work. So hashing is basically a way of taking any object that you find in your OSINT investigation, anything that's made up of bytes, be that a Word document, an Excel document, a database, a photograph, a screenshot. If it's made of bytes, it can be passed through a long, complex mathematical algorithm and produce what we call a hash, which is a unique signature of numbers and letters. That is completely unique, first of all. No other combination of bytes could possibly produce the hash that matches your document. Secondly, it's irreversible. So if I just have a hash, I can't work back from there to rebuild the original document and find out what it was. And it proves authenticity because hashes are unique and because the combination of bytes that make up your data and that you're relying on in your investigation, it could only produce this particular hash, as we'll see shortly. It proves the document is authentic. And it also proves the data is unmodified because I cannot take some evidence I find on the internet and then present it to someone else and without it and being able to show that it hasn't changed. So a hash, if a hash hasn't changed, it will prove that I have not modified that data. And I will show you a visual example of this in a moment. And lastly, it's irrefutable. If I find a document on the internet and I hash it, and then I present it at court 6 months or a year later, or I publish it in my newspaper article, and the hash hasn't changed when someone compares it, it is absolutely irrefutable that I have not altered or modified that document in any way. So when people say, oh, this is fake, or it's been altered, or you changed it, that accusation then falls flat because we can use hashing to prove that that is absolutely not the case. So how does hashing work? Well, I mentioned everything you use in your digital evidence and your OSINT work is made up of bytes, like everything on a computer. So the photograph I showed you at the start of the waterfall is a JPEG file. I think it's about 7 megabytes in size. So that's 7 million bytes. The image on the right here is what that photograph looks like in a piece of software that allows us to read the bytes rather than see the image. And on the right-hand side here, every pair of these little letters and numbers you see here represents 1 byte. So there are 7 million of those little bytes that just make up that image. If even one of those bytes changes, the entire hash of the image will change. So if I want to rely on this for my evidence and I hash it, it should match at court or wherever I present it down the line. But if even one little byte in my digital evidence has changed, the hash will be completely different. I'll show you what that looks like. And finally, I haven't shown you one yet, but perhaps I should. This is what a hash looks like. So I take my file, let's say, in this case, let's say I found a PDF document on a corporate website, and I think it's incriminating for the company that I'm investigating. So I've saved a copy of it to my hard drive. I take my PDF and I apply a hashing algorithm to it, which reads all through all those bytes, like we just saw in the last photo, and it produces an output of random letters and numbers at the end. And that is what we call the file hash. That is the signature. That is the bit that shows that we will rely on to show that it hasn't changed or been altered at any point whilst we've had it. So that's what a file hash looks like, and that is what the process looks like. So practical stuff now. How do you hash a file? How do you incorporate this into your workflow? How are you going to take your OSINT work to the next level and start to add that little bit of polish? Now, if you're the sort of person that dies a little bit inside when the command line is featured, don't worry, we're going to look at a graphical way to do this. I'm just showing you what exists within most operating systems that allows you to do this. So in PowerShell, if you're a Windows user, there is a function called getFileHash, or a commandlet called getFileHash. You just say getFileHash, you point it at the file, my secret document.pdf, and tell it to output the format as a list. It tells you the hashing algorithm, which I'll discuss shortly. In this case, it's called SHA-256, and it produces your hash of your document here. In Linux, the same function is built in there. It's called SHA-256sum. It does the same thing, and you point it at the document, and it will. You can either print it in the terminal, or you can save the hash to a text file. And on macOS, it's slightly different to Linux. In this case, you just use the command SHA-sum, and you tell it to use the A flag to use the SHA-256. Again, point it at the document, and then you get the output as either as a string in a terminal, or you can save it to a text file if you prefer to do that. That's how you can hash with the command line. I prefer to do it in a GUI, but if you are doing a large amount of files at once, or you are scripting, then it's easy to be aware of that these command line tools exist. So how can we do this in GUI? Well, I'm going to show you how to use a tool called Quick Hash, which is freely available. It runs on any operating system, Windows, Linux, or Mac. You just download and install it very quickly. And this will give you a bit of an idea about how hashing works. So first of all, I can just hash a bit of string, meaning a row of text. So if I say here, welcome to SANS OSINT Summit 2021, I choose my algorithm, which is SHA-256. And down here at the bottom, it gives me a long hash, which represents that string. And it's only possible to produce this hash with that combination of letters. If I changed any letter, even the case of any of the letters there, this hash would look completely different. I mentioned algorithms. One of the things about hashes is that they are irrefutable and unique. But a few years ago, some mathematicians discovered that some older hashing algorithms like MD5 and SHA-1 could theoretically, albeit I don't think it's ever been demonstrated in practice, theoretically, you could produce the same hash from two different inputs. So those standards, although they still exist, are regarded as deprecated, and we don't use them. The standard on Windows and most operating systems is to use SHA-256, which is proved to be good for now. So I just showed you how to hash a line of text, but we can also hash a file as well. All we have to do is upload a file into Quick Hash, select it, and we generate a hash here, which you can see here of that file. But if you remember, just a few minutes ago, I made some alterations to the metadata on this file. Now, can you tell the difference between these two images? The short answer is you could stare at this all day, and you couldn't, because visually, the content of these files is absolutely identical. They have the same file name. The bytes that make up the content of the file, the actual image itself, are completely unaltered. All we did was alter the metadata. So if I want to check whether a file is legit or not, whether one is the same as another, I can compare two files in Quick Hash as well. So I select file B, which you see the file name ends dscn0010.jpg, and the altered file. I compare them, you see how different the hashes are here. And what's caused the hashes to change is the changes we made to the metadata earlier. So if I had an original, I'll be able to tell you, do the comparison here and tell you A, whether or not the file had been changed and was therefore no longer reliable, or which of the two competing file types was actually the unaltered original. And Quick Cache says, this is a mismatch. It means one of them has been altered. When hashes don't match, it can tell you, it tells you that an alteration has taken place, but it cannot tell you what the cause of the change was. So in that case, you would be able to see that the chain of custody in handling that particular file had been broken, even though the image to look at was absolutely identical. So back to the question I posed earlier on, which is the original image? So you see the hashes I just managed to fit in next to the photos here. The original photo had a hash beginning with 173. And then when we put the other two images to the hashing algorithm, you can see the one on the left has not changed, and the one on the right has got a completely different hash. And this illustrates a point about just how small the changes need to be to trigger a different hash. All I did on this was to add one single pixel to the image. A pixel in a color photo is 3 bytes. So 3 bytes out of I changed 3 bytes out of 7 million that make up this image, and it gives a completely different hash. You could not have detected that visually, most likely, unless you have amazing eyesight. But as soon as you start hashing things, you can show that I have changed something, I have altered something. And if this were a more complex file or collection of files or something that's hard to scrutinize visually, like a database and so on, you would be able to see beyond all reasonable doubt that I had altered or manipulated that file. The chain of custody had been broken, and therefore, according to the guidelines that govern these things, that would not be useful as evidence, and you open yourself to criticism. On the other hand, if I can show that I've maintained the integrity of the file, then the hashes will match, and we'll be able to see beyond all reasonable doubt that I have not altered or manipulated the file in any way, and that my evidence is reliable. So how do I add this into my OSINT work? There are a couple of ways to do this. I'll give you an idea of your workflow may vary to mine. This is how I prefer to work, and I've done this kind of thing. But when you're doing OSINT, you are constantly gathering material from digital sources, whether you're saving web pages, you're taking screenshots, and so on. As you're doing that, you should be recording what you did and why. And there are many, many different ways to do that. People like to write things down, make mind maps, and so on. When you have gathered your files, but before you do your reporting, you should be hashing all those files using one of the tools that I've demonstrated here or something similar. And you should be documenting those hashes so they sit with the file. That way, when you present your evidence in whatever situation that may be, there should be a collection of the hashes along with your document. That way, anyone who wants to criticize it or scrutinize it will be able to verify that, yep, this evidence that Stephen's presented here hasn't changed, it's legit, and it's authentic. And I'll show you a quick mock-up of an OSINT report done this way here. So this is a sample OSINT report. I will actually just mention very briefly that if you use Hunchly or you are aware of Hunchly, which is absolutely one of my favorite OSINT tools, Hunchly will do a lot of this for you as you go along. So Hunchly, if you're not aware, is a OSINT tool that works as a browser plugin. And just as you browse along and look at web pages, Hunchly takes screenshots and captures the HTML that makes up the web page, and it hashes everything as you go along. So a lot of this process is automated for you by Hunchly. It does have limitations in that if you are gathering digital evidence that is not directly from websites, say from a peer-to-peer network, for example, it can't hash that kind of stuff. And you'd have to use a manual tool. But Hunchly is a great way for doing this. So we collect our hashes as we are doing, as we are working and building our report. And I've suggested as a way of presenting it in a way that is intelligible and useful would look something like this. So you'd have your Word document, it would have a reference in your case. I've just noticed it says Excel document, and I've got a picture of a Word document there. So in this hypothetical report, it says Excel document sucker_list.docx, file formats all over the place, containing fraud victim contact details. And I would say where I downloaded it from, which is this fictitious web address, the time and date that I downloaded it, and then together with that, I would have my SHA-256 hash of that document. That way, as the evidence passed through however many pairs of hands, however many people looked at it, however many people would want to challenge it, that hash would sit there, and they will always be able to compare the evidence I found to the hash to see that it had not changed and been altered. What would happen if the hash no longer matched by the time it reached the defense attorney, or by the time it reached the newspaper or the Russian disinfo cell who are wanting to undermine you? If that hash has changed, it shows no matter what you've done, that the file has definitely been altered. But the converse is also always true as well. It will help us to prove that chain of custody. I mentioned that you can hash files. You can hash collections of files. You can even hash an entire hard drive. So because it brings that reassurance and integrity into our OSINT work, we can also apply it whenever we're transferring information as well. So you can hash an entire USB stick, for example. So again, this is a fictitious example where a whistleblower has got some confidential data that they want to pass to a journalist. So along with the email, you say, hi, I posted you a USB stick with the data on. You will not believe how corrupt the government is until you see this. And the SHA-256 hash for the USB is, and then we put the hash for the USB in the email. Then when the person receives the USB stick or the hard drive or the CD, no, so I know it says CD-ROM, who still uses CD-ROMs, but when they receive the hardware with the files on, they'll be able to compare the hash, and they will be able to tell whether the data has been altered or edited in transit or not. And that helps us complete that chain of custody. We've gone right from the collection all the way through to the reporting. And then when we are disseminating our reports, when we are sharing our evidence with other people, by ensuring we have hashed everything along the way, we can prove that nothing has changed, nothing has been altered. And in this, again, fictional case, if the journalist found that the hash didn't match, they would know that someone or something had caused that data to be changed or altered by the time it left the whistleblower, and that you would not be able to rely on it. So that concludes my brief talk on how to hash. I hope that it's been clear and that it's challenged you to perhaps stretch yourselves a little bit in terms of how you quality assure your reporting, and how you can add that extra depth, and how you can make your work really robust and defensible if anyone wants to challenge it or attack it in any way. I will be around for the panel, and I'll be in Slack to answer some questions if you have some questions. But yeah, otherwise you can find me on Twitter or on my blog. I hope that's been useful for you.
Hey, Stephen, we do have some questions that people have posted here in Zoom. Some of these I think you've more or less answered, but I thought we'd go through some as well. One example here is the time that you hash a file. Obviously, how could you prove it was not manipulated between the time it was, say, downloaded and, then hashed?
Well, ideally, it's difficult when you're dealing with dynamic web data because you always want to hash things that are static. Because if I took something from the web and just left it there, there are innocent reasons why it could change as well, just through timestamps and things like that. So this is why in the report I mentioned, you make a note of the time as well. You can't hash something before it comes into your possession. I know that might seem a bit obvious, but you can show from the time and date that you took it to the time and date it's presented, it hasn't changed. And bear in mind, if you're doing this kind of OSINT, hashing is one tool amongst many for assurance. So you might be perhaps you video record you doing your work, or you use Hunchly, or you take a screenshot to prove that I did this at this time and this file has not changed since then. So yeah, documenting when you did something and where you did something and how you did something is just as important.
Right. Yeah. And as one of the other people posted, you know, someone could change that content on the website in the meantime, either, you know, intentionally or just as a matter of changing their blog, what have you. So
yeah, there's it's best to always have a local copy of what you're working with, because otherwise you have no control over it.
yes. Now here's another question. If two hashes are different without manually checking them using some sort of a diff program, is there a way to find out the differences?
Just from looking at hash, no, because a hash is irreversible, you can't go back and find out what caused it. So if you have two files that don't match, or that should match and have different hashes, all it's saying is the bytes in file A are different to the bytes in file B. Yeah, you can't work back from a hash, unfortunately.
But I think that's a good question for people to understand. This is not a reversible process, really.
Yeah.
So, excellent. Let's see what else we have here. Things that might happen with, say, a USB disk. What happens if the drive is modified by the controller? Could there be something that happens within your computer that alters the maybe collection of data?
It depends on. I thought digital forensics questions are always it depends. It should not. Basically, if I have a USB stick or a hard drive and I've hashed it, and then I make an image of it, it would be an image, not a copy of that. There should be no differentiation by the time it reaches you. There is the issue of external metadata, which I've mentioned, which changes, you know, when things were recorded and when they were first opened. That should not affect the data in files. But yeah, I've in that last slide, I've simplified the transfer process a little bit. But generally, if I give you USB, I hash it, and you check the hash of it, it shouldn't have changed by the time it reaches you, unless someone did something bad.
And that sort of leads into another question, which is, are there some diffing tools and things that you have used to possibly look at differences, not directly related to hashes, but
the short answer is no, I haven't. I've generally when I work with this sort of stuff, was if just either using the command line or using the graphical tool like the one I've shown you, which will tell you very quickly. And there are specialist digital forensics tools which will draw your attention to this, but no is a short answer, not beyond the simple tools that I've shown in here.
Excellent. Yeah, I thought this was a great presentation. I don't know from your experience, but I know from mine, say even 10 years ago, and I seldom work criminal cases, usually civil matters, so maybe lower stakes, but I was seldom challenged on digital evidence that I got off the internet, Facebook or something like that. I think that's changing as people become more aware of the easy manipulation of this kind of data.
Yeah, definitely. I started to see it towards the end of my law enforcement career last year, because there are websites now that will generate fake Facebook screenshots, fake Twitter screenshots, and they are visually, they are perfect. Fake iMessage conversations that you can throw into your divorce case. They are there. So these techniques are becoming more and more important.
Yeah, absolutely.